Okay, guess I'll get back to it. To talk about question 3 and 4. Oh yeah. Maybe I want to say a little bit about there's another way to do this type of question as in question 2. I just want to say a little bit about that. I didn't want you to do it this other way, but I should tell you, like, as always, there's a different approach. And I just want to spend like 2 minutes explaining what the different approach is. And the different approach is to say, instead of giving you generators and relations for G and D4, I could tell you all the elements of G and all the elements of D4. Like I could write. So it turns out the elements of G might be like the identity R, S, and then we have no, instead of that I'll put like we have R, identity R, RS, RSR, RSRSR, RSRS, RSRSR. So 1, 2, 3, 4, 5, 6. That's it. We have 8 things. Okay. And then I could tell you that D4 is really like E, A squared, A cubed, and then B, AB, A squared B, A cubed B. And I could also give you rules about how to like multiply them all together, which would essentially boil down to telling you that the rules are like that B squared equals the identity, A to the 4th equals the identity, and like BA equals A cubed B. And similarly for G, I tell you like RS to the 4th is the identity, S squared equals R squared equals the identity. Okay, that would tell you all the information you need to compute in G and D4. And then I could ask you, to find a one-to-one and onto homomorphism between the two. And let's see, I think I would tell you like, so R would get mapped to, I need to check, what did I put? Right, so A gets sent to RS and B gets sent to S, which is this, it turns out. Okay. Now A squared is this, A cubed is this, AB, well, I have to do RS times this, which is just R. AB goes to R. A squared B goes to RSR. And A cubed B, well, that has to go here. Okay. And then the identity goes to the identity. Okay, so I could have, instead of doing it the way I did it, I could have told you like, here's a function from D4 to G. You send A to RS, A squared to this, A cubed to, like, follow all these arrows, and that gives you one-to-one and onto function from D4 to G. And I might ask you, prove that this is a homomorphism. And so then you have to go through and check, like, you have to check, like, here we have A times B. So in D4, A times B is AB. And you have to check that here's a phi of A, and here's, or sorry, psi of A and psi of B. And now you have to check, your psi of AB is R. You have to check this times this equals R, yes or no. If yes, that's like one step on the road to proving that phi is a homomorphism. Okay, so you have to check like all those ways, different ways of multiplying things on the bottom corresponds to the ways of multiplying on the top once you follow the arrows. Okay, so that would be just one step of many of proving you have a homomorphism. Okay, I spent way too long on that, but anyways, so like basically you'd have to like write down a table of possible multiplications and compare the multiplications when you do phi. Then like check that everything matches up, you get a homomorphism. Okay, so I prefer is just my preference that as long as you check that the relations are preserved by phi, and then you get a homomorphism for free, kind of. Okay. Okay. But anyways, so question 3. Luckily, this won't take long because it is just to check compute with symbols. You check x commutator of x, y, and z is just x, y, z, x, y inverse, which is y inverse, x inverse, z inverse. And then you just check x, y, z, x inverse, x, z. You get x, y, z, y inverse, z inverse, x inverse, and you get x, z, x inverse, z inverse. Now you just cancel. You cancel again. You get the same thing as here. Okay, so that is all you have to do. The end. That is it for question 4, or sorry, for question 3. For question 4, there's like some different ways to move with question 4. So anyways, G is a finite group. Order of G is equal to n. We have to show that the order of G to the K is equal to n over the GCD of n and k. Okay. Okay. This was supposed to be a little bit tricky, but well. So first check that G to the K, the D is the identity. Right? Well, let's do that. G to the K to the N over the GCD of N over N with K. Well, that's just the same as the G to the N times to the K over the GCD of N and K. And a crucial reason why this works is because this is an integer. Because the GCD of N and K divides K. If this is not an integer, this like argument doesn't work. But anyways, so you have G to the N. G to the N is the identity because the order of G equals N. So you have E, K over GCD, and K, which is E. Okay, so therefore, this tells you that the order of G to the K is a divisor of D. Okay. So now suppose G to the K to the M is the identity. And what should we do? When G to the KM is the identity, now since the order of G is N, that means N has to divide KM. Okay, now if we divide through by the GCD of K and N, you have N over the GCD of N and K divides K over the GCD of N and K times M. And notice these two numbers share no common factors because we divided them all up. That's what the GCD is. So the GCD of these two things equals 1. And so they have no common factors. So since this divides this product, this thing has to divide M. And that's what we wanted to show. So if G to the K is to the M is the identity, then our proposed order has to divide M. And also G to the K to this power is the identity. So therefore this is really an order of G to the K. And I'll say that's not the only way to do it, but that's just one way to do it. Okay, there's just 2 minutes left in class, but I hope I didn't really want to. I just wanted like 2 people responded to this quick questionnaire, and I found that at points.
Sir,
Oh, someone had a question.
Excuse me. Sir, can you scroll up a little number 3?
Sorry.
Sir, can you scroll up a little so I can see number 3 again, please?
Oh, go back to number 3. Yes. There we go. Number 3 is just like we compute both sides and they turn out to be the same. Yep, no problem. Okay, just in this questionnaire, oh, when is the next assignment? Yes, I want to give you one today. I didn't mean to give you like a little break, but I didn't mean to give you this long of a break. So, but anyways, I'll give you an assignment today, for sure. Just due next week. Okay. Okay. But yes, that is a good point. I do owe you an assignment. Okay. I guess we'll just stop there. We're gonna continue back with rings on Friday. There should be 7. So we have 5 this week and 2 more. Yeah. Yeah. Okay. Yeah, I was talking about the survey. Well, I'll just say a quick thing about it because it kind of is, we're a little bit over, but yeah, if it's okay, I'll just talk about this survey a little bit. There's just 2 responses, and I'll just tell you, like, I don't want to. Just it was helpful for me to get the responses. Someone said that it was helpful in Friday's class. Someone asked me to go back and explain something, and that was helpful for the person taking the survey. And I just wanted to relate that back to you. Well, of course, the person who wrote that knows it, but maybe the person who asked the question doesn't know that that was so helpful. Okay. Someone else, I'll tell you something that was helpful for me to find out from the survey. That's this person likes that there's a little informal introduction before starting ring theory. And that is helpful for me to know, because sometimes it seems like it could just be a waste of time, but it's good to know that it wasn't really a waste of time, it was useful. And I'm happy to try and do that more. Then someone's explained, sorry, this is the last thing I'll say, but there's more on this survey, but I just want to kind of finish soon. But someone says they don't like it or it is confusing when I'm going through a proof, and then in the middle I state and prove a lemma, and they said it's better to do the like whatever lemmas I might need before, and then just keep the proof like one continuous thing. And that is good to know. I will try to do that. Like I will try not to have lemmas breaking up the proof of some theorem. Okay, and there is more helpful things on the survey, but that is the main things that I wanted to let you know about. Yes, so anyways, yeah, that's it for today. Thank you everyone for watching. I'll see you guys again on Friday. Okay. Okay, well, yeah. Enjoy your day too. Okay, bye.